When you discuss reactions, it's really common to want to talk about the energy of the different species in the reactions. And so we need a vocabulary and a method to describe this. Note that we've already talked about energy in this course. We talked about energy axes for orbitals and for things like rotation, about dihedral angles, and we followed the energies of the different conformations. So this isn't new to us, but I want to bring up kind of a new representation. So here we're going to have energy on our y-axis, and then on the x-axis, this is going to be the extent of the reaction. And I kind of think of this as a YouTube video, that this is almost like a time axis. We're watching the progression of a reaction. That's not really what it is. It's the extent of reaction, but still, I sort of think of it as the time bar on a YouTube video. So let's look at a really simple reaction. HCl plus H2O will form Cl minus plus hydronium, H3O plus. So this reaction occurs by having water, one of the lone pairs on water, attack the hydrogen and remove that from the chlorine, and that forms the chloride as the conjugate base and H3O plus. So perfect. We've seen this reaction before. As it turns out, when you mix water and HCl, I'm not sure if you've done that before, but it can get really hot. That's because it's an exothermic reaction. So the products are lower in energy than the starting material. And so we can talk about this. We can say we have starting materials, and we're going to form a product. I'm going to label it product, but you could just as easily write P. And as this reaction occurs, it goes through some process and forms the product. And therefore, for this reaction, we would say that there is a change in energy in the reaction, and it goes downhill. And how do we observe this change in energy? Well, the reaction gives off heat. So this would be an exothermic process. You can have endothermic processes, but for the most part, we're going to look at reactions that go downhill in energy. And so this is kind of a short introduction to how we discuss these processes. And we'll talk a little bit more about different parts of this curve and how we interpret parts of the curve.